I'll just sit
So
there
if you
then.
just sit there.
From one of the desk areas. We've got 2 guest speakers this evening, and we want you to be comfortable throughout. So, yeah, if you want to grab a seat, please do grab one from the desks. I'm Tom. I'm a product designer here at User Testing. I'm just going to do a very, very quick welcome and housekeeping, and then I'm going to hand over to Mike to introduce the speakers, I believe. I'm looking at Mike like, yeah, that's the plan. Yeah, that's the plan. Good, good, good. Yeah, it's a privilege to be hosting this community again. It's one that I have known and been part of since I moved to Edinburgh myself. Always great chats. Always good to meet new people from the industry in the area. So, very happy that I can combine both my work and my community interest. If you don't know us, User Testing is a remote user research platform. We help companies across the world conduct user research with almost anybody in almost every country. So if you'd like to know more about the platform, then come and find me at the end. And I can tell you more. I can help you get access to free tests so that you can sort of understand how the platform works. Yeah, we'd love to kind of get more folks in the area using our product. So yeah, that's that. In terms of housekeeping, there's no fire alarms planned. So if there is a fire alarm, please walk slowly to an exit. There's actually one just behind us here. I guess that's the closest. We're going to try and wrap up about 8:30, I think. So we'll give you the signal afterwards. There'll be some time for drinks and a chat, hopefully, And when we do give you that signal, please leave in an orderly fashion. We need to put the room back and keep my office manager happy. So I think that's everything. So without further ado, I'll pass you over to the organizer, Mike.
Thank you very much, Tom. Thanks very much, Tom. I got my little bit of paper here, otherwise I'll forget something if I don't have that. So yeah, welcome to you all. So yeah, this is the second of our UX Edinburgh events hosted by User Testing, and you know it's great to be invited back, especially after the last time. But no, seriously, it's we're delighted to be welcome back here. You know, it's a beautiful venue. Thanks again to Tom, to Sam, who's not here today, but and to the rest of the crew, Aaron, and the rest of the crew for their kind of generous hospitality. We've got an amazing lineup tonight. So we're kind of stepping onto the cutting edge of things to talk about or to explore the world of virtual reality, augmented reality, and XR as well. And we'll find out what that is. I didn't know, certainly. And we've got a couple of amazing speakers in the shape of Joanne and Mars to kind of guide us through that. So huge thanks to them. Big thanks also to Alan, the man over there, who's going to be live streaming for us again today. So thank you very much for that. And also to Ricky, there he is, who's actually done the lion's share of the kind of organisation for tonight. So I'm just standing here taking all the credit, but thanks, Ricky. And I think that's it. I think we could probably go on. We normally start with community announcements, and I don't really have any community announcements. But if anyone here has anything that they would like to say, any events that are coming up, any jobs that are on offer, then please raise your hand, and I'll pass the mic over to you before we kick off. If you don't, that's fine. But if you do, speak now. The tension. Okay. Well, we can do it at the end as well if you think of something. So yeah, we'll just hand over to our first speaker then, who is Joanna, I believe.
That's right. Hello everybody, it's so nice to see everybody here today. My name's Joanna Aldous, I'm a research associate at Napier. My research focuses on evaluating haptics for virtual reality, mostly handheld controllers and wearable gloves. Can I ask you all to see, just to gauge where we're at in terms of how many of you have heard about haptics or haptic technology for VR? A few, we've got a few. Other things. So haptics refers to technology that is replicating the senses of touch and movement, usually through acoustics, mechanics, or electrical feedback. Today, I want to share with you a UX case study that I've done around a virtual training healthcare simulation to demonstrate how you can successfully evaluate haptics and avoid some common challenges. I should say I'm somewhat nervous in these situations, so I'm going to say I'm neurodivergent, so this is my idea of a nightmare right now, but I'll try my best. If I don't make eye contact with you, it is not you, it is literally, it's me, it is me. I'd like to thank my colleague, Dr. Amelia Sobolewska, who's over there somewhere, for all her support in helping with my research. So what I'm going to say is that anything I tell you today is she's probably to blame. Okay, so there we go. Right, let's bash on. I've got a double clicker situation here. So I'm going to say before I play this a little trigger warning for you. There is some graphic surgical proceduring going to appear. So if you don't want to see it about halfway through, look away. I'm just going to show you some examples of how this technology is used for haptics and VR currently. and just to give you a flavour of what I'm talking about. Okay.
All right, let's move, let's move.
I mean, you're dealing with a generation that's very familiar with cell phones and video games and so forth, so this isn't foreign to them.
All right, move up. A couple hundred NYPD officers have taken part in this pilot training this first week. The goal is for police departments across the nation to endorse this tech so this training can be incorporated nationwide.
I had 10 colleagues from across the service join me virtually, where they were able to see what I was seeing and direct me to investigate the fire scene. It's an incredibly powerful learning tool for the fire investigators, quite an enjoyable process at the same time, so it's becoming a really, really good tool for us.
The virtual reality are that it actually provides you an element of stress that's not disabling to your learning. It also allows you to engage in what we refer to as productive failure. So you basically are allowed to make mistakes and then you learn from them. We compared VR to non-VR in senior trainees in orthopedic surgery, and then we had them perform that same procedure in cadavers. They were assessed by surgeons from across the country. And what they found was that clearly the VR group was superior in technical skill and in safety compared to the non-VR group. And interestingly, the virtual reality group also learned the information 570% faster.
About 3,000 people here watching all of you guys hanging out here in high fidelity. So let's spin the wheel. Let's see who wins an Oculus Rift right now. Let's do it.
Hello. I'm in my art here, painting. Don't you wish you were here in VR?
As you can see there, haptics and VR have got great potential for doing all sorts of things. That were just a few examples. The one thing about haptics generally, though, is that not many people have experienced it. And so the user experience of haptics in VR is generally unknown and its impact to society. Touch generally is an intimate thing. When you touch something, you are also being touched. It can be active, you touch something. It can be passive, something touches you. It can be desirable and it can also be undesirable. There's a level of intimacy involved when somebody puts their hand on your shoulder to reassure you, or perhaps to tell you not to do something. It affects us deeply because it is a primal sense. It carries significant meaning. It tells us a lot about the world. Touching confirms that things are real. You see something, you're not quite sure about it, you're gonna touch it. Is it there? To understand its nature. Is it solid? Is it an illusion? Touch gives us a sense of agency and control. Critically, a sense of ownership towards our own body, towards our own limbs. Perhaps, if your leg or an arm or something like that's fallen asleep, you realise how foreign it feels to you. A sense of ownership towards your limbs can be appropriated to create a sense of ownership towards a virtual avatar. This is what makes VR so immersive, and it gives us a sense of embodied presence. The rubber hand illusion, I've given you a link there, is one such body ownership illusion that demonstrates the process. I've provided you a link and all of the resources are there. You can give it a go yourself and you can try and transfer the ownership from your hand to a virtual hand and feel it as if it were your own. Touch is the first sense to develop after conception, and by comparison, sight takes about 12 or 18 months or so. Mechanoreceptors throughout our body and inner ear are continuously transmitting information to your brain about what and where your limbs are doing in space. They tell you sense of effort, they determine your position in space, sense of force and weight. This is one of my favourite. This is the sensory homunculus. My focus is on handheld and wearable haptic devices commonly used in VR. And as you can see here, the sensory homunculus is showing you the proportion of the brain that's dedicated to each of your senses. And the hands, massively important. And the reason they're massively important, because of their exploratory nature. The skin is tailored to 8 senses. I'm going to read them off here because I'll forget one of them probably. Friction, touch, movement, pain, temperature, stretch, shape, weight, and density. By comparison, the best gloves can only cater for 4 of these: shape, density, touch, and movement. So very, very limited. And proprioception, not so much. Most teleoperated robots can't propriocept. So, on your skin, you have a 2-point discrimination. It's called a 2PD measure, and it's your ability to discern 2 nearby points on your skin as opposed to 1 single point. And you can discern on average on your hands 2 to 8 millimeters apart. However, you do have receptors that detect skin displacement as small as 10 nanometers. So to put that into perspective, because you guys deal in resolution, 1 pixel is approximately 263,000 nanometers. Oh, you probably also like to know that your skin weighs about 8 pounds, and I think you've got about 27 feet of it. I don't know, I'll go with that. Do this. Right, let me just go back there, skip something. So, one of the challenges with your skin is the fact that unlike most of your organs, your skin is multifunctional and it's distributed. So it makes it impossible for a single haptic device to cater to the complex multisensory nature of your body. And touch acuity diminishes with age. It also varies from person to person. So if you're going to design something for haptics, you have to test for that and you have to factor it in. But back to the point. Because you cannot have a single device that can cater for the multisensory nature of your skin, most haptic devices are context specific. And so they vary greatly in form and function. These are just a few of those. There's a lot. So, to the case study. Okay. The case study was for a loop insertion procedure. It's a relatively simple procedure whereby a small device like a contraceptive implant is placed through an incision in the chest cavity to monitor the heart in case of abnormality. The battery lasts about 5 years, and all it means is that that information is sent to an app, your doctor can see it, and they go, oh yes, you're fine, John, or no, you better come in and see us. And it means you can go for that aerobics class that you were planning to go to, and you don't have to unduly worry, oh no, maybe something's wrong. So it's very helpful. The procedure is undertaken on average 50,000 times a year in Scotland alone. The procedure is new to nursing, however, no virtual training is available for this particular procedure. By the way, you won't view any blood or anything like that, so don't worry. Currently, healthcare students generally will watch somebody doing the procedure one time. They will then undertake that procedure under supervision one time. They will then undertake that procedure on patients by themselves going forward. So aside from the way that they can practice these types of things, a lot of it's out of books. Okay, sorry, I'm going to go with this one. This is a haptic touch stylus for 3D systems. It has some positional sensing. It can move up and down, side to side. It provides force feedback. It comes with its own SDK. On the left there, you can see a 3D model that was developed of the loop insertion device. And not only was it developed for the virtual simulation, it was also developed as a model to be attached to this device. These types of devices are commonly used for virtual medical training because tools such as drills, scalpels, and other instruments like this loop insertion device can be attached to it to recreate the exact look and feel of the tools used and the feedback that somebody would receive. That's about it. Now, there was something I meant to say there that generally speaking, medicine has a long history of using haptic devices of one kind or another. Either models, dummies, you would have seen them, those compression dummies, or cadavers. Now, in this case, for these sorts of things, if you're going to do brain surgery on somebody, right, you've got to use a cadaver. There's no model in the world that's going to do that. Problem with a cadaver is they're kind of hard to get a good cadaver. And when you get a good cadaver, only one person can have a go. And once you've kind of had a go at a cadaver, you can't like have another go. You've kind of ruined the cadaver. So virtual haptic training is really useful. You want people who are going to poke around inside of you to get as much practice as possible, particularly at things that go wrong, right? And the problem with models is you're not all the same as a model. If I cut into you and I expect to see an artery here or thing here and it's not there, and I've only learned from a model, it's not going to go well. Okay, so in my research, here are some of the dimensions that I've identified that are critical to a haptic user experience. The joy of use, the ease of use, the purpose of use, these are set things that are already components of UX, but the items listed under them, you can see where they sit. Those are the things that I've identified as being critical to those things. Realism, immersion, satisfaction, aesthetics, perceptibility for haptics, safety, performance, wearability, handling, usability, well-being, engagement. And all of these things create emotional reactions from the haptics, okay? Feelings, facial expressions, physiological, and so on. And these lead to quality judgments. Ultimately, these affect behavior and motivation to continue to use the thing that you're putting in front of somebody. So just to explain very, very briefly what some of these things are for you. So where we talk about wearability, as opposed to something wearing out, we're talking about portability and ergonomics and comfort, that type of thing. Handling includes control, stability, manipulation, transparency. Safety includes physical, psychological, and reputational. Now, I just want to focus on safety a little bit because haptic devices in some cases manipulate your hand. And so repetitive use can cause some physical issues. Also, you've got to consider that somebody can touch you remotely. We're in VR, and this allows a complete stranger to potentially interact with you physically. Not just verbally or visually, but physically. And that might not be wanted, right? And some people find certain effects unpleasant also. So there's these other things. If you put something out in the world as well, there are reputational consequences to your company if you get it wrong. Perceptibility includes detection, recognition, clarity, and expressiveness. How expressive is the effect? Usability, I think we mostly know about this. The operability, the learnability, the accessibility, performance, the effectiveness, the efficiency. And for haptics, we also have the transparency. So we have a thing that says if haptic transparency is that the device performs so well that it becomes unnoticeable, it becomes invisible. There's no longer an interface between you and what you're doing, it just is there. The sensation is just there. Realism, affordances, synchronicity of all of the different senses, what you can see, what you touch, what you hear is happening, the fidelity of it, immersion related to presence and embodiment in virtual reality. So haptics, generally touch, has a lot to do with making you embody the virtual avatar. Feel as if the virtual hand is your hand. It feels like your hand, it looks like your hand. And then satisfaction, pleasure, comfort, trust, usefulness, engagement, challenge, curiosity, adoption, and then well-being. Well-being is a new one, eudaimonic, security, self-actualization, and competence and fulfillment. This is quite new, really, to UX and also to quality of experience for engineers. And this is kind of has implications for the continued device use, but it enables a user to have autonomy, to realize their goals in a meaningful, enjoyable and fulfilling way. So in of itself, it is enjoyable just because. You can see the items that have been measured there. I've marked them with a little star. I'm just going to go through the measures for those. So these are the things I measured for this particular instance, so I'm going to show you in a little moment. Safety, performance, usability, satisfaction, realism and engagement. So for safety, we're looking at anxiety inventory for pre and post test. Anxiety is really useful indicator of fear but also stress, and it's useful in evaluating safety, particularly in virtual reality. Participants have been found that suffer from anxiety, not suffer but are experiencing it maybe prior to using something, that they're more likely to suffer from simulation sickness, and it's more likely to break immersion. If you are not aware that your participants are having some level of anxiety, that have implications for your results. So you need to take that into consideration. People who are not suffering from anxiety are much more likely to have a good level of immersion, and they're much more likely to have simulation sickness. Task performance was captured. Obviously, we're trying to get them to train to do this procedure. We were capturing things like procedural errors, number of reinsertions, the instability of what they were doing with the tool. We used the NASA Task Load Index, which is a really common evaluation measure for cognitive and physical workload. How much effort, how hard was it for them? Usability, again, how usable was the simulation? We looked at satisfaction and realism. So realism, we took the simplest measure just to see where that would go, which is a visual analog scale. So I don't know, for those of you who may not be familiar, it's a 10 centimeter line that says not at all realistic, completely realistic, and it's really simple because they just put a cross where they feel, and then you just measure it and you get your averages that way. And the final thing for engagement is flow. So flow is really useful for measuring engagement. It's the optimum user experience because it relates to the intrinsic motivation of doing something because it is enjoyable and fulfilling in of itself. Intrinsically motivated experiences are more effective motivators to do something than an external extrinsic reward. When people love what they do, they're more likely to participate and do it again and tell other people about it and get them to do it as well. And also, they're more likely to execute the task successfully. And you're probably going to find out in a minute from the results that it bears that out. So, this is a virtual training simulation. It comes in 2 versions, normal standard procedure. This part procedure, I'm going to show you the gamified version, which was designed to evoke engagement to positively affect user behavior. The only difference is the procedure is identical, and I can't say this enough. The procedure is identical. The only difference is that if they're successful, they get some upbeat music, okay? And if they fail, they get a dejected, oh. They get a dejected sigh. The loop insertion procedure itself is absolutely the same. You're going to see now a failed attempt and a successful attempt. To the user, I want to reiterate this well because you can't tell this, but to the user, the skin and everything in this scene is solid to them. They cannot penetrate it. Only the incision is penetratable. And if they go in at the wrong angle, they will be forcefully and physically pushed out the incision, which you're going to see. So let's just have a look at that. You can hear them butchering my machine in the background. You can hear it toiling with the gears. So they've realised that you see them being jotted out there. Will they get it? They're nearly there. Now they need to rotate. So they're not noticing. Oh, they've figured it out. Yes. Oh, they've gone out of alignment again. They've gone back. Here we go. They're going to do it. Finally. Oh. Oh dear. Oh. You should have heard them as well. They were all like, oh, like that. This is the same person. This is their very next go, by the way. This person did 11 successful attempts in the end in under 10 minutes. Believe it or not. No, they know straight away this time. They know straight away. They're like, oh, different angle, here we go. It's quite funny. I'd sit there silently while they muttered away to themselves. Oh, they know they've gone the wrong way. They know it straight away. Yes, I have faith. Yay! So I had to give them a little reward. So they got BG staying alive. It's somewhat apt, I feel like. I originally wanted to do a heart that they could use an exoskeleton to keep alive to that music, and the health and social care said no. Never mind. Here we are. Right. So to the results. So what I want to point out with this, the virtual training procedure generally provided good usability, although the participants, you know, it was challenging for them. You can see that. But there were not massive significant differences between the task performance for the both groups, and you can see that there. What you are going to notice, however, that is very straightforward, is that at the first attempt, very, very hard. But over time, with each subsequent attempt, over time, it gets dramatically easier. They make far less errors, far less faults, and the time drops significantly. And I believe after, let me just check my numbers here. Yeah, at the first attempt took 4.5 minutes on average, with 49 errors and 5 failures. And by comparison, the third attempt took just over 1 minute with an average of 7 errors. And after 4 attempts, there were no further failures. And you see this in the procedural system data as well. Now, what this is really useful at illustrating is if you did a standard usability test, user testing, and they had one go, you would have classed this as not usable, right? Because you would have done one thing, try the task, it didn't work, you took 4.5 minutes, this is terrible. But this is a learning thing. So this is over time. And so if you're doing tasks, actually it's really, really useful, because otherwise you just wouldn't get that pattern. So get people to do things a few times there. What it indicates, and this is, you know, it's mirrored in the other data, what it's actually indicating is that though it is difficult, they get better with practice. And they reported that it was very interesting. Holding the device was challenging, coordinating the hand was confusing, but it was really enjoyable. And they wanted to do it again and again, and they really liked this way of training. And so, you know, you can see it has a good level of learnability. That's what you see in it. Okay, to the benchmarks. Right, I'm going to state this out loud. I'm not a fan of benchmarks, right? So we've got gamified and normal version here, and you can't really put much between them, right? SAS score, okay, good usability, fair to middling, no to low anxiety, medium workload, It doesn't tell you much about really what's going on. And benchmarks are great to give to stakeholders. Benchmarks are for a quick, like, is it a thing? But they're not really going to tell you much, and they don't explain why. They don't explain their own result. You just are going to get a number. We only have 2 significant results at the bottom here. So we can see, yeah, it's got all the good stuff, usability, medium workload, low, doesn't give much anxiety, it's realistic, great. The gamified version was better than the normal version. I think we probably could have figured that out for ourselves. And the flow state was higher for the gamified version also. They entered more into a state of flow. However, if we interrogate those and you check the anxiety pre-test, they're very similar, 8 and 9 for low score. Here, where we look at the post-test, normal and gamified, you see a very different set of results. And what you see is that even though they were generally content, relaxed and calm when they started, when they finished, the gamified group are very much more tense, worried, slightly stressed. 100% of the participants in the normal group felt content, relaxed and calm, although 28% were somewhat tense at the end. However, 2/3, 71% felt somewhat moderately tense after the gamified training, and 14% felt worried. So it indicates that aspects of gamification can make users feel more anxious than they started before. So it's just something to consider. If you're going to start thinking about, oh, it's really nice to add lots of gamified elements, right? It's not always going to be beneficial to everybody's kind of well-being, depending on what it is. I think there are good levels of stress, optimal levels of stress. Another way of looking at things was the flow. So we had two figures there, and we could tell one had a slightly higher sense of flow than the other. This is a radar graph, and what this is actually showing you is what are the averages for all of the questions around flow, the dimensions of flow, and you can see what the shape of the experience was for flow, the challenge to skill balance, where the action and awareness started to move or merge. Whether they had clear goals. And you can see from the gamified version that there's a greater loss of self-consciousness. They forgot about being self-conscious. A transformation of time. They lost track of time. Action and awareness started to merge. And so you can start to see the differences and what's actually going on that those benchmarks are simply not going to tell you. Right. On to the useful stuff. Common challenges. You're going to evaluate some stuff in VR, possibly haptics, maybe not. Your biggest challenge right at the top there is going to be latency. Haptics, they have to respond to something more or less in real time, within 400 milliseconds anyway, for them to feel like it's a real thing. And so you're only as good as your machine. You're as good as the signal is to get to the machine, to then take that interaction, to then send back the feedback for them to respond to it. So any lag is going to really pick up, is really going to affect performance. Straight away, your evaluation is out of the window because it's not going to reflect what's going on. Equipment calibration, as I mentioned, touch acuity, that's different from person to person. If you're going to use sensors like an EEG, that's an extra bit of kit that's got to be fitted over a virtual reality thing, and you've got gloves and you've got this other stuff on there. That's all got to be calibrated. It's hard to analyze. And then location. So you've got some VR gloves. You're going to put them on people. Well, gloves are one size. People's hands are not one size. So depending on where the sensors are going to hit the hands, they may or may not perceive what you want them to perceive. With haptics, because a lot of it is mechanical, sometimes it's acoustic or electrical, because in many cases it's moving or continuously touching the hand, you've got an issue around fatigue, particularly for force, where it's pushing back. So you get tiredness of the hand, you get repetitive strain where you're asking them to do something again and again, and you get desensitization. After a while, I'm just not going to pick up the same sensations on my hand. Because we touch things a lot, but it's not continuous. Breaking immersion. If people are anxious to break immersion, lots of equipment can break immersion, and also the equipment noise and weight. So a lot of this stuff's got like pneumatics, some of it hasn't, but generally there's motors, there's something involved, there. So this is another challenge. And then hygiene. You're going to be putting all this equipment on different participants. You've got to wipe that stuff down. The major thing for haptic user experience that is a real problem. It's a real problem industry-wide. Now, I've spoken to haptic engineers around the globe. It is just a common issue. Participants are not familiar with haptic technology, and people are not familiar with describing the sensations and their experience of touch. You might say, oh, it's a bit sticky or something. If I say to my participants, how did that feel? And I ask them there, how does that feel? They say it felt strange. I say, in what way was it strange? Or I don't know. Somebody said to me, oh, it felt like dried cucumber skin. I went, oh, that's really helpful. Thank you so much for that. So I'm going to give you a method which I have developed. It's a hybrid approach which I developed to avoid breaking immersion because you can't do think aloud during virtual reality, really. If somebody's going to be immersed, they can't be talking to some external person about what they're doing. So this is, I call it the HURT method. It takes the HURT out of evaluation. So I did that. I worked ages on that acronym. Hybrid user-related retrospective think aloud. It's a real tongue twister. Essentially, it's going to allow you to get quantitative, objective, empirical benchmark, and an average across time. What you're seeing here is a rating, basically, what is your user experience like from poor to excellent. Very simple. Poor, fair, good, very good, excellent. You break up the stages of your virtual simulation, of your haptic experience, whichever it is. So essentially like your user journey, like your stages of your task. And afterwards you record, you video capture their session, you play it back to them, and they rate those things. And while they're rating those things, as you run through the video, you say to them, how did that feel? What were you thinking? Literally, what were you thinking? What were your thoughts? And what you're seeing here is an aggregate. This is an aggregate of them. So I've kind of built a user journey of what they actually have. They're able to articulate it a lot easier. Another handy thing that this allows you to do is this. So this is an aggregate then of each stage that you don't get for a benchmark. You essentially can benchmark each stage of the journey. And it tells you on average how those were. And you can see inserting the tool for the normal group versus the gamified group, very different experience. It probably meant more to the gamified group. But what it allows you to do is to see sections of the journey that may need improving, sections of the journey that are doing well, and you can still get an overall ranking. So the overall ranking for this, for both actually, was 4. Very good. Generally, they thought the user experience for undertaking a loop insertion, procedure using the haptic device was very good. And that's kind of what they did. There you go. And that's me pretty much. Any questions? I'll try my best to answer them.
I'll try and get around to
Oh.
Thank you, Joanna. Just to ask, sort of, what is the opportunity now and in the future for UXers in this space?
There's not a lot. So they're really having, so to kind of quantify this in some way, haptics and VR, the first haptic VR device was 2009. And that was only possible because of mobile technology, shrunk all the semiconductors and all the screens and all the little sensors and things. So it's very, very new to the field of engineering, and certainly in VR. And only now, I'm one of the first people probably in UX. Massively, it's not really a thing. So I would say in virtual reality there are UX people. There are very few in haptics, and there are even fewer in haptics and VR. So I would say massively. For example, the School of Health and Social Care alone is looking to transfer much of their medical training procedures to haptic virtual reality. Different types of industries now are looking to do industrial training for robotics with haptic virtual simulations. So I think it's just an expanding thing. It's just finding those companies, because even haptic companies themselves who manufacture this equipment are few and far between. It's very expensive to do. So it's a massive area. But like, here you go, right? I'm one of the, I would say now, leading experts probably in the world on haptic UX evaluation. And where would I go to get a job? Probably a haptic engineering lab, possibly in Germany, maybe in America. I can't get a job here. Probably it's very difficult. There's maybe a lab over in Glasgow. I think there's a VR haptics lab in Glasgow that they might let me peddle about with some stuff. It's a challenge. It's a challenge. So I would say there's a lot of scope for it, but it's not, there's not like loads and loads of jobs sitting there. So there's lots and lots of potential, but it's quite specialised, it's quite niche. Does that answer your question? Ish. I didn't think about the prospects. I just thought it was interesting, so I kind of went there. I mean, what new UX-y stuff can I do? It's interesting.
My name's Joseph. Thanks very much for the presentation. It's great. I have kind of, and I'm formulating this as I say it, so it might not kind of line up very well, but in terms of how you're defining haptics, the image I had in my head, I think, was video games that you play in virtual reality and something happens and it hurts, right? Like this is what I had in my head when you mentioned it. But it seems like you've got touch as an input that's then manifest in some sort of virtual space, and it gets kind of feedback there. Touch as an input that then outputs in another physical space. So this is your guy with his robot arms, you know what I'm talking about, kind of operating them remotely. Yeah, and then I suppose, yeah, then that's my next question. Is it, how much, is it the same equipment that generates touch as an output? So if I'm the user, I can experience something happening elsewhere that I feel directly, as opposed to my touch being an input that changes something. Does that make sense?
They're both things at once. I know that doesn't really help. So I have a haptic glove. It is both taking my feedback, my electrical, mechanical potential into that glove, relaying it into the virtual system. I'm interacting with that. That is synchronizing that movement and those effects, and then it's relaying the information back to my hand. So if I move my hand like this, hopefully the virtual glove visually does this. The glove that I'm holding understands I'm doing this. And as I go to pick something up and I touch it, it is relaying the sensation of that object haptically to that glove. And it very much depends on what devices you have. So there's teleoperation, where I may be, say, doing surgery or moving a robot and I'm touching an object, I don't know, like I'm repairing something outside the space station, the ISS or something like that, right? And I've got a little robot on, but I need to know how much pressure I'm applying. I need to know whether I've picked up the thing or not. And in turn, me doing that, putting that level of force into that device, even whether I'm doing surgery, is going to relay it to the machine. The machine is then going to relay back to me the amount of force that is being applied to the object. So it's a two-way, continuous loop, and that's why latency is a real issue. If latency is there, what can happen is I can overcorrect because something's delayed, and then what you get is you end up getting a fishtail situation. It's like when you overcorrect in the car, and you can cause real damage. I mean, if you've got a big robotic machine in a factory and it's not relaying the synchronizing the feedback, and you're overcorrecting with a little joystick at this end, that thing's going to whip around. But yeah, you're right. You can also do it in a virtual reality game, and I can wear a haptic suit. I can wear some haptic gloves. You can shoot me. Maybe it hurts. I'll probably turn down the effects a little bit. I'm not really up for it.
Well, but that kind of relates as well, because I can imagine a situation where you're operating something physical and you're getting the haptic feedback, like you mentioned there. I can't see any reason why you couldn't build a virtual object that did the same thing within a virtual space and fed back the feedback. But I don't.
You're building haptic effects into the virtual environment. So you're saying this object's solid, this object's slightly spongy. These effects they're all programmed. It's just telling the glove that, it's just relaying that information to the glove or to the tool or to the device. But it's all built into the virtual environment, if that's what you're doing. In the same way that if I was using a robot to teleoperate something and I wasn't in VR, it would be built into the robotics and the sensors. So it's just a slightly different way of getting the feedback. With the haptic 3D stylus you saw there, there's actually an SDK for Unity. It has a whole bank of effects. It's really, really useful. And actually what I meant to say is I actually bought some of my equipment over here. It's very simple equipment. During the break, you can have a little go, because it's very difficult to describe it. You kind of have to experience, and I'll be here later also if you want to do it later on, because we only got a short break, haven't we? We've got a short break.
I have more, but I don't want to link with the mic.
Hi there, that was a really interesting talk. I was wondering though, if you're able to tell us a little bit about your background and if you come from a medical background, because I mean obviously this kind of technology is obviously very relevant potential.
I'm kind of, I would say, a digital dinosaur to some degree. I started off web design when you were a webmaster, back in the early 90s when the internet became a thing, and people still had yellow pages. And so my background was as a web developer, and then I went into user research and then UX and did a degree in that. But I worked most of my time as a senior digital consultant, delivering online services for loads of corporations, that sort of thing. I kind of did that to the point of UX and evaluation and research and HCI and all that thing. I wasn't really learning anything anymore. And I went, this looks interesting, maybe I can contribute something to my field. During my undergraduate studies, I did the rubber hand illusion, and I wanted to see, can you do it with a virtual hand? And I had some great faluting ideas about, I'm going to get a VR glove and this is going to be excellent. They're going to put the glove on, it's going to be awesome. No, the technology was not there. You were talking about pneumatics and pistons and things that, like a glove that weighed 6 kilos. I was so underwhelmed and I was so angry about that it caused me to do a PhD in how to evaluate, to help them design slightly better gloves. Yeah, and here we are today. So.
You're talking about how poor the technology was a few years ago. And I imagine that the technology is getting better at a really rapid rate. Where do you think the field's going to be in 5 years' time?
So at the moment, really where we're going now is soft robotics. So we're not even talking about pneumatics, or we're talking about electrical muscle stimulation. So you're seeing things where you can just have it on your arm and it'll just manipulate your hand. Like you're not even wearing a glove now, you're just manipulating your hand. If Elon Musk has his way, and he has done his way for brain transplant for people with cerebral palsy, and I mean, more power to him, right? I wouldn't take that away from anyone who has cerebral palsy, to control the impulses of their muscles. Really important and useful thing for them. But once you've done that, once you've cracked that seal open, you've said, we have safely put an implant into somebody's brain. His view of the world is that, why use a keyboard as an interface when you can just interface, right? So that's potentially where it could go. A lot of people have an issue with that. Personally, I think you're going to see haptics. I mean, when I was talking to hapticians about this who are currently working on this, the people on ISS were using haptics to maneuver vehicles under the sea. And I was like, why would you do that? Well, because you want to know, how can you steer something in zero gravity, right? People using it for nuclear fuel rods, because you can't let a person in there. And if you're going to remove a nuclear fuel rod, you've got to know how much pressure you're applying. People using haptics to steer trucks in the Congo in war-torn areas remotely to provide supplies and food. Really, where I think it's going to go, where you guys might encounter it, is the metaverse. Everybody is pushing for it to go to the metaverse, because what do you do with a 2D internet? You make it 3D. What do? You don't go visit Amazon on your page, you walk through Amazon. You go to the aisle that you're interested in, you pick up the things, you try the things, you're there. You work there. You do aerobics with people in the metaverse. We shake hands in a meeting. That's where it'll go. I think the challenge with that is that whatever we do socially, we bring with us. And we see what happens in social media space, that will happen in VR space, and it will get more prevalent. Maybe you don't feel like doing that. I'm not going to go into metaverse, not interested in metaverse, right? Same people like Facebook, I'm not into Facebook. But your children, their next generations, are already doing it. They're already going there. It's something that is going to happen. It's just a matter of how long. I honestly think like 5 to 10 years' time. The challenge with that is harassment, interaction. There's benefits to it as well. You can have a long-distance relationship with somebody. If you have dementia, perhaps they can haptically interact with virtual recreations of their family that don't go and visit them much. Maybe you can give your child a hug when you're not there and you have to work away for a long time. I don't know how humans, what the impact to society would be if haptics became ubiquitous and you no longer really relied on having real physical interaction with people. Because the simple fact is, you see far away and you hear far away. You don't touch far away for a reason. So if you are suddenly able to touch remotely, what impetus is there for you to have a close day-to-day relationship? So, on that note, cheery, cheery, happy, happy.
Thanks very much, Joanna. That was awesome.
Welcome.
And I'm sure we're all pretty excited to play with the kit over there. We're going to take a 15-minute break, I think. So if we get back in maybe 10 to 8, we'll be back here. Cheers.
Let's do this. Really? Are you going to?
Yeah, over to you, Mas.
Thank you. Hello, everyone. Thanks so much for coming tonight, to all the audience and to whoever is watching as well live. I'm Marzena. I'm a lead UX user experience at Born Studios. And thanks so much again for coming. So today I will take you for a wee journey through who I am first, and then what we're doing, and I will try to create this overview of what UX for virtual reality is in a nutshell, because in half an hour it's really hard to tackle all of this information. So first of all, I just want to show you a little bit of my journey, how I got to the UX for virtual reality, and what was basically the work experience and education. So I did study at School of Art in Poland. Then I arrived to Edinburgh and I studied at Edinburgh College Interaction Design. Then I went to Napier University, dropped after 2 months because I decided to go to the field and find a job. And what I did, I educated myself mostly for AR and VR via online courses, but also into a little bit in psychology too. So I landed my first job at Symbasync, which was website design and app design. It was SaaS product. It was very difficult, very hard job, essentially for a junior designer. Was working with content data. But then I went into Sublime, which was immersive experiences. There was a project company. So we worked on many projects, essentially with platforms like massive pods, HoloLenses as well, and then VR experiences too. So that was like the biggest experience I got in there. Then Sublime transformed into Edify, which was a product company, and I was their principal UX. Then I went to SideQuest, and currently I am at Born Studios. So first, what I want to know is, in the audience, how many people knows the difference between AR, MR, and VR? Just raise your hands. Awesome. I mean, not many from the audience I see, but that's good because my next slide will be actually useful. I'm going to show you more or less what is the difference. Today we'll be discussing VR, but I wanted to give you a little bit overview of what the differences are. Essentially, XR, it's extended reality, means it's an umbrella for all these three mediums. But AR is a view of the real physical world with an overlay of digital elements. What does that mean? It's the environment doesn't respond to any digital element that you're overlaying on it. So you can put any UI to your application, and it just overlays over your real world. It doesn't respond to the real world at all. Which MR, it's a difference that it is aware of surroundings. It's basically you can put something on your table, and it knows that it's a table. So it interacts with you, interacts with the object, and you can overlay, you can design the entire space around you the way you want. So that's the difference between basically AR and MR, which VR is a fully immersive experience. It doesn't respond to your surroundings, it overlays everything around it, and you see another world, essentially. And moving on. Okay, I will take a sip of water, sorry. Right, let's get some deep into share the knowledge about VR, essentially. And the difficulties, what is out there and what I'm facing every day and what as a UX designer for virtual reality is. So there are some similarities when it comes to VR and website and the process of creating UX for it. But the main differences in here is that in websites and application, we have open source. Everything is available for everyone. There are massive researchers. We have many people who have tested over the years. The website is so old. We've got testings sorted. People knows how to interact with things. We have very common and mental models already created there, which in VR, it's such a niche and new field that there is no many people wants to share the knowledge. That's the problem. We do share eventually. Everyone is so secret about it. Every design, every company wants to be so unique with it. So no one really shares what didn't work and why. And that is very important because what we're doing as a designers, we're doing in a circle, doing exactly the same research over and over again. Every feature, we're doing this again because no one shares their findings. No one shares why that feature has been implemented, what have they tested before, and why that didn't work. And that is super important to understand with every single design process. You know, like if you have been through it, if you know someone has designed it already and that didn't work for a certain product, you will know why you shouldn't use it. But because there is no information, we don't know it, so we're doing over and over. And that takes time. That's why VR and research for it is not progressing the same way as websites. Next one is ideate, test, and repeat. Because these 2 points essentially tackle together because they are dependent on each other. Because there is not enough resources, it's very hard to get proper papers and research. We're doing a lot of ideating, testing, and repeating, but the same process. But that is very important as well itself to set the standards with your company too. And as we know, because it's very new field, lots of big companies set up some standards already. So like Oculus, they share the principles. But the problem here is that they just released 3 years ago, 4 years ago, the Oculus. We still have qualitative data. We don't have quantitative data of what works, what doesn't. So they put all the standards and everyone followed. So you could see what happened with the Mixed Reality Vision Pro. They broke the standards. They bring something different. They went for gaze and hand tracking with totally new approach. It's because they had a chance to explore what happened. They could watch what's intuitive, and they smashed the market. And that would shape the way how we perceiving essentially virtual reality. But what we can learn from that is that even big companies setting the standards for virtual reality UX, we still have a space to explore and not be afraid of following big companies. We should be exploring. We should be checking what is out there. That's why we should be sharing stuff with each other. That's why we need to learn from each other. Make it accessible. We all know products that are accessible are usable, and we all know how it works in websites. However, what happens in VR, everyone forgets about it because in companies, no one wants to spend time. It's somehow more difficult to implement that. Not many people is educated enough in accessibility as well. Plus, VR is a totally different field. You're not only considering accessibility for UI itself, like a panel's UI, but you also need to think about presence and virtual reality space and how the user with mobility issue will walk around, how they will interact with it. There's lots of controllers, like how do we make that actually accessible? So it's a lot of knowledge that goes in it, and not many people actually spend time to think about it. But the main thing to do it is to start from beginning and consider all the constraints and all the limitations and obstacles at the very beginning and create like an MVP version for your accessibility approach too. Because that is very important to understand what are the obstacles, what you can do to make it accessible enough, what you can do after too. And prototype. And I'm not talking about prototyping in some application. You can literally print it out things. You can stick on your wall. You can stick on your fridge or whatever. You can try it out. You can see how is that responding to you, how far it is, how big the UI is, or what panels you want to do, or what sort of how the text readability is as well. So prototyping is very important, but that is in a nutshell. So obviously every presentation has to have a quote. What I love about it is it touches on our UX field and UX soul. So virtual reality is the ultimate empathy machine. It helps us to wear the shoes of all others, not just walk in them. Okay. So what is UX for virtual reality, and how does it differ from the website UX design? So let's dig into it. So I just wanted to mention quickly that video is not playing. There you go. I just wanted to mention that all the videos that I included are in this presentation are actually from the projects that we worked on in my company, so I will dig into what we're doing. However, immersion and presence. So 3D world, heavy focus on depth and spatial awareness, spatial sound, 3D visuals, haptics, and psychology of human senses and responses, understanding of how much overload is on each sense, understanding how to maintain the balance, and knowing what to do to kind of reduce the cognitive overload over all the senses. Where in website, you've got two-dimensional task. It's very important, though, to create immersion, especially in the game design. But website and games, they don't have sense of, they don't require sense of physical presence, essentially, which in VR, that's what you want to, that's what you're gaining for. You want to make the virtual reality experience real. You want your users to believe they are in different world and knowing how they, how to interact with it, what to do with this, you know, and understanding their surroundings. You don't want to make them uncomfortable. Next one, it's in VR, we're also using gestalt walls, and this is an example which is amazing because we're doing this now a lot in our environments. So we're using different laws for different purpose, but basically law of closure, you can see how that builds up. It's an example of PC game, however. I could not put some examples of what we use that for in our projects, but I will give you an overview how we're approaching it. So law of closure creates a sense of understanding your surroundings. It kind of directs your eyes of where is the main point of view, where you should be looking and where you should be directing. Law of continuity, it gives alignment. So user is not overloaded with information they're receiving from the environment, so it's much easier to navigate and understanding what's happening in front of you. Law of symmetry brings balance, and again, because normally we want to direct this consciousness clues where to go for the user, you can see the middle is the goal you should be approaching to. And law of common fate, it gives the user, guides the eyes down the straight path as well. Like gives the very easy and smooth direction where we should go. Another one, which is amazing actually, we all know as a UX designers how shapes creates atmosphere on the website, right? We know that there are some shapes that we use for certain products. We know that if you want to make it more professional, we might use more shapes that are square. If you want to make user-friendly and more for like fun, we're using a more rounded and obviously more balanced. But we do use that in VR as well for environmental design. And I will show you the example of this. So you can see in the picture, our user, it's a game again, PC game, but we're doing this exactly the same approach for virtual reality. I don't know if you can spot any shapes so far. Just take a break and test yourself if you can see any shapes around and what does that, where you could maybe place the strong ones, you know. I'll give you a second. Okay, let's move on. There you go. So you can see the area of don't worry, of the save area, is for the user when they land, most likely. You want to keep them safe. We want to make them comfortable. We want to prepare them for the task they are about to do. What we want to do most of the time in the environment, the area that is out of focus, we want to play with the light as well. This is as well supporting lightening in the scene too, of course. But shapes as well making the first impression. So you want them to watch out, being aware of this, but not being interested of the areas that are not out of focus. However, you see the main point of view, the main goal is square. It's something that can be used as somewhere I should be going, which is a very powerful tool. Instead of using cues, UIs, and overwhelming user with the cognitive load of information, we are playing essentially with senses, with understanding of environments, and we're directing them to the goal they should achieve. Next one, interaction. And these videos are playing me today. There you go. Interaction, consideration of the user whole body interaction, including gaze, voice commands, walking or physical movement, motion sickness avoidance too. Where in website, you've got touch and mouse or another input device primarily, which considering accessibility too. And in websites, you've got more direct interaction, include clicking, scrolling, swiping, and typing. And now I'm making it so easy. It's not as easy as it sounds. You all can argue with me. But that's basically the main approach here. Interaction is very, not advanced, but like it has much more detail because you're not only thinking about interaction with panels, you're also thinking interactions, users versus application itself. You want to think about how you will interact with the 3D objects, like how will you approach them. You've got different senses to use, you've got different, as well, accessibility, how you help the user to interact with things, how you make it easier. Who is your audience? Like, because that is very important, like who are you designing for? Is you designing for kids? That will be another approach as well. You will know there will be different set of interactions, essentially. Yeah, user interface, that's the fun one. UI elements are often spatial, meaning existing in 3D space around the user. What's distance? Like, there is a lot of consideration with user interface itself. It's how far we'll put from the user. What will be the set of interaction? How will the user be approaching it? Will the user interact with it from the far away? Will that be both? What the user interface will be like. Will that be diegetic? Actually, how many people knows what diegetic UI is? Hey, perfect. Diegetic UI is using existing elements from the virtual space, like table, like laptop, and overlaying user interface in there. That means the user doesn't require flat UIs. They can go just to the 3D space, 3D object, and interact with that. And how important the diegetic interface is especially it doesn't break the presence because it's naturally placed in there. And what we're doing, we're reusing real-world elements for the user, and they know straight away to interacting. However, if they don't feel present, if they don't feel immersed, they won't know there is something interactable. So how do we make that very clear for the user? There's something to interact with. So that's how we're playing with highlights. That's how we're playing with lightening. That's how we're playing with little things of UI interface to make them direct to the goal. And we're using the previous laws that you saw, direct and use to the goal. With the lightening, we're making that much, much lighter. In this scenario here, you can see the video, which is not playing again, but that's one of the applications I will show you later. You can see how that panel, so that's essentially the lectern, and it's in front of the user. We made it 3D, so the user knew where the button is, and knowing this is by the way a dummy. This is like kind of testing purposes. So that's the prototype we're doing, and then the back panel you can see in here. That was the design. Our design did amazing job with it. However, with just to show the difference, the interface in webs and apps is constrained by the screen to this space. Elements like buttons, forms, sliders, and cards are used to structure the interface logically, and they need to follow specific guidelines for the usage to be intuitive. So they are much better with structuring, and we all using the entire knowledge of what is being implemented for website and the general user interface. However, we all need to think about what the angle, how far, the text, the size. Will the user grab it? Will the user resize it? Will we give them a power of moving around it? And that's there's a set of another constraints coming with setting up your scene and customization, which we all need to think about scenarios, about use cases, who we're designing for. Is that useful? Is that not? Will that bring the present? Will that bring the benefit to the application? Or will that make it more complicated? So all of this consideration needs to be taken and thought through. Content consumption. So virtual VR experience is an active experience. Users can choose where to look. Yeah, user can use not only where to look, but also where they go, if we allow them. They are not constrained with setting the boundaries. You know, on the 2D screen, you've got very clear path. You read, you scroll through, you're swiping, you read the content, and you're moving forward, and you know your goal as well. In VR, as you can see on this video as well, there's so much going on. We need to be considerate of cognitive load too. Depending of the task, depending of the application, we need to make sure we put priority of a form and what the user is about to accomplish. So if in this scenario, you could see user sitting in the cockpit, If we put an overload user with UI, that would change the entire goal of the application, because here the goal of the application in this scenario was to teach them how to put the engine on. If we put too much UI, they will break the presence, they won't understand what's going on, they won't put too much thought into what they're about to do, but they will be focusing more on the UI itself and what does it serve. And that means we're playing with cognitive overload. That means we are doing a bad job because they are more focused on the UI itself rather than on the task. So that is another consideration of content consumption, how we're doing, when we use it. I will talk about this application a little bit further. These just are quick examples. And here you go. Accessibility. And this is a subject close to my heart. By the way, look out for the book that's coming out in January 2024, which I'm contributing to a chapter about accessibility to virtual reality. But there are, however, many chapters with neuroscience as well. Very interesting to read about and see how virtual reality affects all these senses and the brain as well. But with the accessibility, this is still ongoing research and development. Everything is new. We are basing our knowledge on setup principles for website and application, but also gaming, because gaming is much closer to VR than website itself. But because it's so new and because it's so niche and because we're still testing it with people and we still have this qualitative data, we are exploring. But that's the important thing. It's to be keen to explore rather than say, no, I'm not doing it because there is not enough research. And what we're doing with accessibility, you can see a little bit menu. That's one of the application. What we do, we've got a set of basic, advanced, and intermediate goals that we want to do with accessibility. So we want to make sure we include everyone. But for the basics, there is very easy guidelines to try to include everyone. Because, you know, accessibility, essentially, you're not designing for people with disabilities. You're designing for your future self. Because anything can happen at your workplace. You can break your hand, you can have a baby, you can have a phone call, and you need to perform a task. And that's all is also part of the accessibility. If you cannot perform task and multitask, the application is not accessible. So all those things need to be thought through. And at the beginning of your process, it's very important to do it. But the difference with the website is essentially you don't have to think about motion sickness. We have the need for physical mobility and the potential for visual and auditory overload risk. There's a lot of things going on that little movement can cause motion sickness. Lots of colors going into, you know, we're playing with actual fake environments. So with the people with color blindness, we might overload them with lightning. People might get headaches from overload of the light too. There's a lot of going on we need to consider, which on the website is not as much consideration. I mean, I'm saying not as much. I'm playing with fire in here, but okay. So I would like to introduce you to the company I'm working for. So we are Born Studios. So at Born Studios, we are creating immersive experiences with different kind of setup for projects. We designing for everything. You can see metaverse. We can see different types of modeling. You can see environments as well. Our mission is essentially to create visual solution and help clients to discover more innovative and efficient ways to do business. And we are multidisciplinary teams. Each member of a team wears many hats. We're trying to own our processes as much as we can. We're always supporting each other, and I think this collaboration of teams with, I'll just let it, yeah, there you go, that's the Born. The highlight of our creative team department, that's creative team department. I'm not talking about production, project managers, QA testers, and all of that. I'm just highlighting the beginning of the production when we starting. So we have set of people in narrative design and UX UI designers. We've got 3D artists, developers, and audio designers. And we all working very closely. And I'll show you in a bit of the process that I have in the flow, how closely we're working. But before that, our design process in a nutshell, just quickly to show you the similarities actually, because they are as many differences for a website, but there is also similarities. So we do brief analysis and production estimation from each team. So as soon as we get a brief, we are taking it, and the leads understanding the brief, they're highlighting what needs to be done. Then we're collaborating together, what needs to be done, how much time we need for achieving that goal, and how many people we need in a team to achieve that goal too. Then we go into research. We're doing computer analysis. If it's required, if we didn't get information from the client, we're supporting that ourselves. We do UX research, which is the feature research. We do personas if we're not getting any, and brand guidelines and design direction. Then we go into ideation, narrative flow. Narrative flow and UX are very similar, which I will show you later. However, they are massive differences too. UX are much more detailed. So I always like to say, narrative is a skeleton. UX is muscles, development and art, and other themes are essentially skin and other parts of the body, of human body. So without skeleton, you can walk. Without muscles, you can walk. Without skin and soul, you can walk either. You can't be alive. So I like to have this compromise, this kind of visualization of how each team's input is very important and how important it is to work together from the very beginning. And that's what we do at Born, working together from the very beginning, that everyone understands the brief. And you can see UX pass, meaning in our team, it's after narrative flow has been done, we do UX pass. What we do is we adding the components of auditory cues, voiceovers, haptics. We're doing lots of visual effects as well. So we are preparing the flow to be ready for each team to be able to read that through. And component creation, which is obviously haptics, UI, audio, and development. OK, so are you guys ready for our work? It won't be as great presentation as of the haptics was. I hope I will show you a little bit of the overview of what we're doing. So first project, which was called Impulse Dynamics. This is an immersive experience showing a medical audience how an innovative heart failure device works from the effects on a patient well-being through the muscles and organs and down to the molecular level. This experience was supposed to be showcased on the events, so we had to consider standing, sitting experience, or just passive experience where the person would sit down, put the headset on, and not doing anything. So we had to think about how can we provide the interaction, but also set of presentation essentially for a person. You can see on the left here, this panel was still testing, so you could see that the placement is different. We were testing different positions for the user, where to locate the user, what is the most comfortable to access that. We all knew it should be in front, it's in the right access. But this video is very shorted down. You can see it's speeded up. What it has a set of videos, audio, voiceover. So the voiceover walks the user through. Then they watch it, they hear the patient talking, and they can see how their health improves, and they can play again. Our audience was medical, so basically doctors who goes in and checking the effect of the medical device. So they wanted to understand how does that affect the muscle, how does that affect the heart, what is the difference, what does it do? So we had to all display that in application. And we had a month to accomplish all of this. So that was very rough month. It was very quick, but we accomplished very great effect. Thanks to the team collaboration and very, very talented team. As you could see, in a month to achieve that, it was, we are very proud of ourselves. So process. I won't walk you through the entire process of research and personas creation, everything, but I will show you the transition of the mirror board and how do we do that. So this is the flow. We're working with one flow, which can be accessed by any member of the team. So essentially developers, audio designers, 3D designers can take that information and read that through. But I'll walk you through a little bit. But you can see 4 columns. That means this was just ideation at the beginning. So you can see how that experience kind of degraded later on. So it became much simpler, and simpler, because that's what we do. We creating first the biggest interaction ever. Then what we're doing in investigating, is that too much? Is this too much effort from the user? Will they have losses to perform? How much time do we have to spend? How long is the event? Like, how much time do we need for that? So you can see how that slowly was reducing from the interaction. And then eventually we're ending up with very simple but very cool experience that is very accessible and anyone can use it, and it's quick as well. So it doesn't require lots of users' input. But from the closer look, you can see different colors. So different colors is assigned for a different team. So you have white one, which is UI designers, yellow one is for audio, gray ones are for haptics, and visuals are for 3D designers, but also sometimes for us. So we are kind of sharing that together. And each of them is numbered. So every team receives its Excel spreadsheet, unfortunately, but they all follow. We're still working with Excel, don't worry, it is you can't replace that. But everyone knows what needs to be done. The same with the voiceover. The voiceovers as well are different numbers. So everyone know the number, know what needs to be designed, and especially for the haptics, which I will talk a little bit, and it's an overlap, but it's very different experience here too. You can see audio and haptics, they are very close together, and I'll tell you why, but they work, so they need to be presented together. So we are working that way. So you can see on the left side, we've got visual flow, which what we're doing is supporting any UI. So we're trying to make that as well storyboarding experience. So everyone knows at which point they should design each step and interaction. So we are aligned together. Okay, so haptics, there was an amazing question actually. A person asked how UX can contribute into haptics. And I will tell you that no one from like when I joined, I'm the one who's doing haptics because no one else can do it. And I didn't do either. So I took that and then I asked my developers, we sit together and it's like, how can we improve that experience? Because there was a lot of custom haptics. There was not only sort of vibration, but there were like lots of haptics which has to be customized, for example, for briefing or for interaction with cockpit. There are different audios. So audio needs to be very similar to haptics because it plays with your senses. So how do we customize the vibration? How do you make that work? And so that the person is disoriented, like it needs to be aligned together. So there's a spreadsheet. So what it does, it has some values. So we've got repetition, duration, intensity, and that's the simple one because that doesn't work for customization. The customization has also different is in, is out. It has a different levels of vibration. So all of this needs to be very clear, communicated to the dev team. So this is the simple one. And what we do, we also need to specify which controller will be responsible, where will you feel it? Because if you feel all the time on both, it can be overwhelming. I don't know if you ever tested any virtual reality game, but some games or some applications just overdo the haptics. They are very strong and it breaks the presence. So we need to be very considerate as well about the intensity of the haptic. So you are still conscious about what you're about to do, but the haptic doesn't break the presence. So you can see a lot of items, and that's very simple spreadsheet, by the way. We've got another one for another application. It's like a double size. And that's kind of process of UI, how we take in our flows bit by the bit. And for each part, you can see we split it out, and everyone knows what UI at which point should appear and what should appear, what effect that has, and how does that interact with the user. Project Vata, and this is closer to my heart because this is something we've created. This is the promo video, and it's really powerful. We are very proud of the application, and it's really, you can see how does that make an impact. So the story behind it is that students who wants to become a pilot, they're working with books only. They have sometimes don't even have a chance to go to a real plane and test out their knowledge. So what we did is we took all that knowledge from the book, we went to the real place, we recreated the entire process, we worked with the company that allowed us to do it, and we put that into virtual reality application. And what it happens, I can't fly the plane, but I can definitely put the engine on. So that's the effect. I was like, we definitely know everything about the cockpit right now. But you can see how important that is to not overwhelm the user with UIs, because the goal in here is to essentially follow the path. And what we have in this application as well is two categories. We've got students and the teacher who goes to live lesson. They are together in one session, and teacher put the steps on. It's a very linear experience, so it shows, you can see, there you go. You've got highlights, you've got a hand who is showing you what to press. Sometimes you get feedbacks, haptics feedback to put on just to make them aware and focus as well. But you can see it was like the teacher talks through, has its notes, walks them through experience. The students watching the entire highlights, they know what to do, and then they're going themselves to the practice session and they're performing the task themselves. So what they do, they take in that live lesson, understanding of what they're supposed to do, then they go into practice session, they by themselves, they need to perform a task, they need to accomplish the task, and they are supported with clues, with if they lost, we provide the clues, we provide the highlights as well, so they understand every single thing, what they need to go through. And that is part, I wanted to show you kind of difference between narrative flow and UX flow as well. So that how we're starting narrative flow is very structured. It highlights what step, where UX flow, you've got much more detail. I'm taking that information, breaking that into pieces, and then putting that into work. So you can see auditory, haptics, visuals, and voiceovers, and that's how we're splitting that. Yay. Okay, I hope I covered. Yes, thank you. Any questions? Thank you very much.
Thank you, Mars.
Thank you.
That was really interesting. Does anyone have we got 10 minutes? Where's Tom? We've got 10. Yeah. A couple of questions. Time for a couple of questions, and then we'll let these good folk go home. Yeah. Does anyone have any questions?
Hello, I just got a really quick question. Thank you so much. That's really interesting, and understand your process is it's not dissimilar. Thank you. I was like, I wonder if this will be completely alien, but not dissimilar. I was wondering, are you able to, or do you add textures, or are you able to add haptic shape, textures, and things like that? I couldn't find many virtual interventions where they were doing that yet. So.
Here,
do you think you will?
I think it's a great point, because I am a team of one of haptics, and I'm definitely always looking for more to explore in that area, because I see a massive impact how that could benefit the application. But we're not looking at the textures yet. What we're looking mostly is how can we compromise or contribute audio with the haptic itself, because we've noticed, and there's a lot of research going into, especially for the vibration, because I'm not talking about like devices, but when it comes to controllers only, how can you put them together and make them similar, so those two senses working together, and that creates even better, less cognitive load, and makes it more essentially like real. So that's what we're looking at. But that's a great point. I would definitely make a note of that, and I'll talk to my company. There was a gentleman behind there with the green.
Regarding the motion sickness, I think it's all about the environment that we see is different than the environment we are now. For instance, the acceleration, velocity, or the angle we are across the Earth. So, do you think that additional devices should be supported in addition to the VR headset, because it's our discrepancy between our brains and our bodies that's causing this motion sickness? What is the future of that? That's what I wanted to ask. Thanks.
With the motion sickness, there's much in depth of understanding what each person feels, because for some people one thing causes motion sickness, one doesn't. Some people watching screen or movie makes a motion sickness because that's how sensitive they are. With devices support, no, but what I would say is the technique that you're using, what is currently existing there. It's a tunneling effect that helps. What it does is a peripheral view. What it does, it focuses on, what it does, it narrows down your point of view. What it does for your brain is takes less information. That means it's much better and focused on what you see in front rather than the entire experience and entire environment. And playing with that effect really helps and really provides their big success. We use that peripheral view quite often for our accessibility aspects, and that really helps and reduces. Some people are very sensitive, and that can be fixed. Probably with the devices coming in, the better performance will definitely help that, because of the frame rate will be much more realistic. Because with the motion sickness, very often what it does with your cortex, too much information receiving, and it doesn't meet the real life experience. You see what you shouldn't be seeing. and for brain it doesn't make sense. So having that peripheral view, it really helps for the brain to adjust and get less information that it requires and make sense much faster. So that's what we do. That's the one technique among few that we do, and that probably is the future of helping the user with that.
Thank you. Well, quite close. Thank you for your sharing your journey so far. What would you recommend to people who want to go get into AR and AR UX? What are the steps towards that? What sort of transferable skills, or how do you become a UXer?
First, I will say, if anyone wants more information from what I will provide now, just please do contact me. I'm always more than happy to talk about my journey. But I think if we talk about AR, VR, and XR, what we need to think about, what we need to understand is much closer to filmmaking than to website. So any skills connected to storyboarding, any skills connected to narrative, any skills connected to interaction design, are much more welcome, you know. Definitely this. And I think looking into psychology, because psychology of senses, psychology of human behavior, that is very important. I think for me, the journey with psychology I have, which I'm self-educated, it really helped me to understand how the human brain works, how does it respond to things, and everyday things by Don Norman, essentially, it tells you all about it. It's really the core of how virtual reality works and how the people respond to the word they're receiving, the perceiving. And I think that the main one, but then there's lots of aspects. I think there's lots of courses that helps you too, but practicing like a freelance projects and showcasing UX skills and making that real, it's very important, because when I'm hiring people, what I look at is the UX process and how they're perceiving the VR, what they've done towards creating interactions as well, like how they look at the interactions. So that's the main one. But please do contact me so we can talk more. Perfect.
Thank you very much. So I think a few of us will be heading down to the local pub, as is customary. So I think we're probably going to Brewdog, just down the road. So it's out of here, left. Just a couple of minutes walk down. So yeah, please do join us. But thank you again to User Testing. Thank you to our speakers today, Joanna and Mars, and thank you to Alan over there for doing the live streaming as well. Can you give them all a big hand? Now scram.